Hello everyone. Today we are going to start up with a new chapter, that is laws of motion. Okay. It's a very important chapter as it makes the basics of our particle dynamics, in fact the entire mechanics. It makes the basics of our entire mechanics. Okay, so the first thing that we are going to study here is about the force. What is force? Now if we talk a 9th class student about the force, then what the student will say is that force is something which is a push or a pull. Okay. Also force is something which can do can either change the shape of a body, or if it can change the shape, or it can change the motion of the state of motion of a body. Okay, or it can change the direction of a body. Okay, so next thing is this, that what are the major types of forces? If we talk about the major types of forces, what are those? Okay, so types of forces, when we are talking about, there are 4 types of forces. The first one is the gravitational force. Okay, and the second one is our electromagnetic force. Okay, so when we are talking about types, the first type is gravitational. Gravitational force. Okay, second one is electromagnetic. Electromagnetic forces. Gravitational force is the oldest one, the first force that was discovered, and that was given by some scientist, Newton. He gave this force. Okay, then the third one is the nuclear force. And the fourth one is the weak forces. Now we will discuss about all of them one by one. So let us take first of all our first force, that is our gravitational force. So if we talk about gravitational force. Now, what is a gravitational force? Gravitational force is something which acts between two bodies having mass. If there are two bodies and they are having some amount of mass, okay, so let us suppose that this is m2 mass body and this is having m1 mass, and the distance between these two bodies is r. So these two bodies, they will attract each other with some force, and that force is equal on both the bodies, and that force is given by G m1 m2 upon r square. So this force G m1 m2 upon r square, which is and this formula was first of all, it was given by Newton, and this force is majorly attractive in nature, and the cause of the gravitation is still unknown. We do not know what is the cause of the gravitation, why does the gravitation happens. Okay, we know that some body attracts other bodies. We know about the planetary motion, which is described on the basis of gravitational force, but we do not know what is the basic cause, why does it happens. That is unknown. Now In this particular chapter, that is the laws of motion, we will be talking about the force of gravity. So gravity is nothing but it is a gravitational force only, but that gravitational force, that earth, gravitational force exerted by earth on its surrounding bodies. Okay, so this force of gravity, this is also called as weight. Okay, it is also called as weight. It is also called as weight. We can call it as weight mg also. Its magnitude. Let's talk about its magnitude. So this force is equal to m into g, where m is the mass of the body and g is the acceleration due to gravity, and it acts along the center of the earth. Okay, so it always acts along the center of the earth. Let us suppose that if we have our earth somewhat like this. Let us draw the earth. Okay, so if we draw this is our earth, if there is a block which is kept on the earth here, so what will happen is that the gravitational force that will act on the earth is like this. It is acting towards the center of the earth. Its value is mg. If we take our block to the other side of the earth, then the gravitational force will act in this way, in the upward direction, like this. Okay, it will remain same. Now when this body is attracted by the earth, in the same time it also attracts the earth also, center of the earth. Okay, so this is called as the weight. Now in this chapter we will be having some situations like this, that there is an inclined plane and that inclined plane is having an angle theta, and if we have a block here, then this block is having a weight that is mg, and the direction of that weight mg is towards the center of the earth, and it has got two components. So you need to remember that mg sine theta is the component which acts along the inclined plane, and this component is always mg cos theta. You can very easily calculate it also. How do you do that? If this angle is theta, then this angle is definitely going to be theta, this angle. Okay, with simple calculations you can do it. So the component of mg in this direction will be mg cos theta, and in this direction it will be mg sin theta. Okay, so gravitational force acts on all the bodies which has got the mass. So this is all about this. Then we move to our next type of force. Okay, that is our electromagnetic. Electromagnetic forces are stronger than the gravitational forces, and they are numerous in nature. There are so many electromagnetic forces in nature, different types of electromagnetic forces, but here we will be studying 4 types. Okay, so let's talk about them. The first type of electromagnetic force that we are going to study in this chapter is the normal reaction. Okay, normal reaction force. Second type of force that we are going to study in this very chapter is the tension force. And the third type of force is the friction force. And the last type of force is our spring force. So these are the 4 major types of forces, electromagnetic forces, that we are going to study in this particular chapter, but this doesn't means that only 4 types of electromagnetic forces exists. In fact, we are surrounded by large number of electromagnetic forces. Okay, so if we talk about the normal reaction, so what is the normal reaction force? If we talk about this, let us consider this is ground, and let us consider a block which is kept on the ground here. Okay, and this is the center of the block. Its mg is acting in the downward direction. Now which force is balancing this mg? If we see, this is the interface. Okay, this is the border or the boundary where the two bodies are in contact. At this contact, a force acts, and that force acts from ground to the block. This force is called as the normal reaction force. Okay, now this normal reaction force is balancing the weight mg in this particular situation. It is balancing the weight mg here. Okay, so this normal reaction always acts perpendicular to area of contact, and it acts towards the body. So how does it act? Normal reaction acts perpendicular to area and towards the body. Okay, so this is how the normal reaction acts. Now when we are talking about the normal reaction,